So now we're going to start talking about one of the final topics of the year, okay? And we're going to start talking about sequences and series, okay? So here we go. Um, we have what we call arithmetic sequences and geometric sequences. So we'll begin with the arithmetic sequence and maybe give you a couple examples. So here's an arithmetic sequence: 5, 8, 11, 14. Here's another one: -6, -2, 2, 6, 10. 1/2, 1, 3/2, 2, 5/2, 37, 38, 39, 40. So let's try to determine what is it that determines this, okay? Or like, so what's the next term in the sequence? So 5, add 3, add 3, add 3, 17, get you the next, add 3, 20, and so on. This seems to be a progression, adding 2, starting at -6, adding 2. Or excuse me, adding 4. Adding 4, 2, add 4, 6, 6 add 4 is 10, 14, 18, 21. This seems to be progressing by stepping up a half each time around. Okay, 3 halves, add a half is 2, 5 halves, add a half. Okay, this adds 2. So the arithmetic sequence is tagged, okay, as a progression of numbers whereby there's the difference between any two consecutive numbers of the sequence is a constant. 14 minus 11 is 3, 11 minus 8 is 3, so that's what tags an arithmetic sequence. 38 minus 37 is 1, so there's a common difference between consecutive terms. We call those things terms, and we might tag them. The first term A1, second term A2, A3, A4. So talking of arithmetic sequences then, okay, we give that sequence. We say, what is the sixth term? Well, we got 1, 2, 3, 4 terms. So can we find the sixth term without finding the fifth term? Well, yes, we can. We found the fifth term here, 17. The sixth term is 20, okay? But what if we were asked to find the 50th term or the 100th term? So we want to have a process that would streamline this for us. So that's what we're going to be looking to develop here, okay? So so the question that I pose here is, can this be done? Can we find the 50th term without having to find all the 49 before it, or the 100th term without finding all the 99 terms before? So that's where we're going now, all right? So we're going to look at these in general, these arithmetic sequence numbers in general, okay? So so we agreed to the following, okay? There's a common difference between any two consecutive terms. So the second term, A2, minus the first term, A1, that's some difference value, okay? For the one we looked at previously in our example, the difference was 3, okay? But we're just going to keep it in general now. Okay, so between the third and the second term, the common difference is D. Between the fourth and the third term, the common difference is D. So on and so forth, okay? So if we rearrange these terms, we could say that A1 plus D produced A2. A2 plus D produced A3. A2 plus D produced A4, so on and so forth. Or alternately, okay, A1 is the first term, which sometimes will just drop the subscript, okay? A1 is A plus no difference, okay? It's just no common difference. A2 is the first term plus 1 times the common difference. A3 is the first term plus 2 times the common difference, okay? A4 is the first term plus 3 times the common difference, okay? So, and again, as we said, for the first term, we might just drop the subscript, just call it the A term, okay? When expressed for a term far into the sequence, a general term, so if I'm talking about the 50th term, the 100th term, the 2000th term, I might just refer to it as the nth term. If I were only talking about 4 terms here, the nth term would be 4. Generally speaking, I'll call it the nth term. So the question is, can I find the nth term, okay, the 50th term, the 150th term, without having to find all the preceding? Well, the answer lies in this sequence that we kind of see here, okay? And as you can see, It always depends on the first term, the common difference, and the number of terms that we're moving on. Okay, so like here, the fourth term was the first term times 3 times the common difference. Fourth term, 3 times the common difference added to the first term. So generally speaking, we have a formula that will find for us the 50th term, the 100th term, what have you. It is the nth term is the first term plus, okay, the common difference times n minus 1. So when we wanted the, for our sequence 5, 8, 11, we see our first term was 5. We see the common difference was 3. Okay, so we were asked to find the 50th term, which is the first term, plus 49. That's 50. That's for the nth. We're going up to 50, so it's 49 times 3 plus 5 is 152. The 100th term is 5. The first term plus 3 times the common difference of 3 times 99. Okay, so that's the 302nd term. Okay, now up to now we've been talking about sequences, and as a matter of fact, I think I might leave it at that and resume in the next presentation with this series. So, okay, so what we know, what we found out in this, here was, okay, that we have a formula for finding the nth term of a arithmetic sequence. Arithmetic means, again, it progresses by adding a common term to each successive term, okay? And we found a form for finding what the nth term is. The nth term is the first term plus n minus 1 times the common difference, okay? And we'll resume with the discussion in the next video.